In this lesson, I'm going to discuss server virtualization.
This video is brought to you by EpiPies Academy,
which is one of the main enablers of cloud computing. It allows for resource pooling, where multiple customers share the same underlying server hardware. And resource pooling is one of the essential characteristics of cloud. But server virtualization has been around for a lot longer than cloud computing has. So let's take a look at what we had before virtualization. In this example, it's actually from one of the first companies I worked for, my real first job in IT way back in the 90s. So I was working for a fairly small company, and we were looking after our own servers in a server room. So we had a rack to put the equipment in, and we had a few servers in there. We had an email server, which was running Microsoft Exchange, and we had a database server that was running Microsoft SQL, and we also had our own web server in there as well. Now, obviously, we're going to need power for those servers, so we had a couple of uninterruptible power supplies. These provide power, and also if the grid power goes down, they've got batteries in there, so they'll continue to provide power for a period of time. We're also going to need switches in there as well for connectivity between the servers, and also for connectivity to the PCs in our office as well. And we had some other offices, so we need connectivity to get out there. We also needed connectivity out to the internet, so we had a router and a firewall for that. Now, the router and the firewall, they could be part of the same piece of hardware, or they could be separate. Also, you'd maybe want to have two of them in there for redundancy as well. So that's what we had before virtualization existed. Now, if we're going to look at a schematic view of this, so the blue rectangle here, that represents a single physical server. Down at the bottom level, we've got the hardware in the server. So we've got the CPU, the processor, the RAM memory, and the NIC, the network interface card for our network connectivity. Directly on top of the hardware, we install the operating system on there. And then after the operating system has been installed, we'll install our application on there. The first instance was our email server. So we're going to do that for our mail server, and we're going to have the same thing for the database server and also for the web server as well. So it's 3 servers running on 3 physically separate pieces of hardware. Now, when we do it like this, the server utilization leaves a lot to be desired. And when I say server utilization, I mean how busy the CPU, the RAM, the NIC, etc. is, the hardware that makes up the server. Now, typically, when you're running a single application on a server like this, it's going to be running at maybe around 15% utilization, which obviously is not very cost efficient, particularly as we had to pay for each individual server, and they're all using power, taking up rack space, and requiring cooling. So what I would like to do to get better utilization is this. So here again, I've got one server. I've got the hardware down at the bottom level, the CPU, the RAM, and the NIC. I've got my operating system installed directly on the hardware, and then on that one server, I'm going to install my mail server application and my database server application and my web server application as well. So if I did this, obviously this is going to give me much better utilization, because rather than having the 3 servers running on 3 separate pieces of hardware, I'm now running them all on the same piece of hardware. So that one piece of hardware is doing more work, it's getting better utilization. But putting multiple applications on the same server is very bad practice, because if I have a problem with any one of those applications, then it's liable to take all 3 down. I don't want to do that. So there is a way that we can actually get the higher utilization running all the servers on the same piece of hardware, but without running them all on the same instance of the same operating system. And we can do that through server virtualization. So here, the big blue square, that is our physical server again. Again, down at the bottom level, I've got my hardware resources, my CPU, my RAM, and my NIC. And then what I do on top of there now, rather than installing a normal operating system like Windows, I install my hypervisor on there. My hypervisor is going to come from one of the server virtualization companies like VMware. So this example, let's say I'm running VMware ESXi as my hypervisor. The hypervisor acts as the operating system on that physical server, and it also does another job, which is it allocates access to the underlying hardware to my virtual machines, which is coming next. So let's have a look at that. So I've got my first virtual machine, which gets installed in my hypervisor, and in there it's got its operating system. Let's say that virtual machine 1 is running on Windows, and then on top of Windows I install my email server on there. Then I install a second virtual machine onto that same physical server. And in my second virtual machine, it's also running Windows as its operating system, but this is a separate instance of the operating system. So virtual machine 1 and virtual machine 2, they act like they're two completely separate servers. Actually, virtual machine 1 and virtual machine 2, they don't know that they're virtual machines. They think that they're just normal servers. And then on top of Windows in virtual machine 2, I'll install my database server application in there. And then virtual machine 3, let's say that this is actually running Linux now. So even on the same piece of underlying hardware, the same underlying server, I can have virtual machines running on there that are running different operating systems. That'll work just fine. And then on top of the Linux operating system, I install my web server application now. So this is similar to what I wanted to achieve before, where I'm running all three of those different applications on the one box, so I get much better utilization, but it still fulfills my security and my performance and my availability issues, because those three virtual machines, they act like they're completely separate servers. Okay, so that's the theory of it. Let's see how this actually works with a lab demo. I've connected into my VMware lab here, and I'm on the workstation which is connected into the vSphere server, which is the management application for managing all of my ESXi hosts, which are the physical servers, and the virtual machines that are running on those servers. So if you have a look over on the left, you can see that I've got two ESXi hosts here. I've got 10.2.1.11 and I've got 10.2.1.12. So that's the two different physical servers. And then if I expand these out, you can see that I've got 4 virtual machines that are running on 10.2.1.11. I've got a couple of XP machines on here, Nostalgia and OpenFiler. And on my other physical host, which is 10.2.1.12, I can expand it out and see I've got a couple of virtual machines running on there as well. So to show you how these are different instances running on the same underlying server, you'll see if I click on XP1, I can select the console in there, and that will show me the screen of this actual virtual machine. So I'll click in here and I can see the login screen for my first instance of Windows XP. Let's send a Control-Alt-Delete to allow me to log in here, and I'll enter my password and then click on OK. And that logs me in. You can see on the desktop of XP1, I've got a text file here which is named 1. If I now go on to XP2 and click in the console you can see that it is a separate console. It's a different desktop. It's a completely different operating system. So XP1 and XP2, they're completely different virtual machines that are running on the same underlying server hardware. Going back to the example we had earlier, this could be my Exchange server and my database server. While I'm in here, I also want to show you the killer feature of server virtualization, which is we can migrate our virtual machines from one underlying server to a different underlying server on the fly without requiring to shut them down and start them up again. Let's have a look at how to do that. So I'm going to right click on XP2 and then choose the option to migrate, and this will open up the wizard. I'm going to change the underlying host. I click on next. I'm going to move it from 10.2.1.11 to 10.2.1.12. So I select that and click on next, and then click next again and finish. And if you look down in the bottom here, you can see the job window. You can see that it's doing the migrate of the virtual machine. Now, what it's doing now is, to be able to do this, the virtual machine, it needs to have its virtual hard disk on external storage. The hard disk couldn't have been using the hard drive in 10.2.1.11. So the virtual machine, it's got a virtual hard disk, which is where the operating system and all the applications are installed. That's on an external NAS or SAN storage system. Then when I do the migration, what it does is it copies the contents of memory from .11 over to .12. The actual virtual hard drive stays where it is on the external SAN. So it moves the contents of memory over to 10.2.1.12 and then it cuts it over. And when it does this, it does it on the fly. It's transparent to anybody that's connected into that machine. You'll maybe miss one ping, that's all. So the implications of this are, this is great if you're the server administrator, because if you wanted to take 10.2.1.11 down for hardware maintenance, then you can just move all the virtual machines on the fly to a different host. Also, for redundancy, if we had, say, a power outage on 10.2.1.11, we can automatically move all the virtual machines over to .12. So this is a super useful feature. Okay, that's everything I wanted to show you there. Let's go back to the slides again. So the hypervisor that I showed you there, VMware ESXi, that's actually a type 1 hypervisor. There's two types, there's type 1 and type 2. I'll explain what the difference is coming up in a second. Our most popular type 1 hypervisors are VMware ESXi, that's what I showed you the demonstration on. We've also got Microsoft Hyper-V, Red Hat KVM, Oracle VM Server, and Citrix Xen Server. Actually, in cloud environments, Citrix Xen Server is very popular because it is the cheapest option to use for the cloud service providers. Okay, what a type 1 hypervisor means is that the hypervisor runs directly on the system hardware, meaning the hypervisor is installed directly on the hardware and it acts as the operating system, and like I said earlier, its other job is to give out access to the underlying hardware to the different virtual machines. We also have type 2 hypervisors. A type 2 hypervisor runs on top of a host operating system. You'll see what that means on the next slide. Our popular type 2 hypervisors, we also have some of those from VMware. We have VMware Workstation, VMware Player, and VMware Fusion, which is for the Mac workstation and player, or for a Windows PC. We also have VirtualBox, QEMU, and Parallels. So let's take a look at how the type 2 hypervisor works. I've got a schematic for you here again, and the big blue box is an individual host. This is probably going to be your laptop now. Type 1 hypervisors are used in the data center, and type 2 hypervisors are used on an individual PC. Again, I'll explain why that is coming up in a second, but let's look at how it works first. So this big blue box, that's your laptop. And on your laptop, you've got your underlying hardware, like your CPU, your RAM, and your NIC again. And then on top of there, we don't install the hypervisor when it's a type 2 hypervisor directly on top of the hardware. This is your laptop and you've got your normal desktop operating system on your laptop. So that's probably going to be running Windows or Linux or Mac. Then on top of your operating system, because this is your normal laptop, you'll have your normal applications like Microsoft Office, Adobe Acrobat, etc. running on there. Then we install the Type 2 hypervisor as another application on top of our normal desktop operating system. And then on top of there in the hypervisor, we'll have our different virtual machines. So here we've got virtual machine 1, which is our email server, virtual machine 2, which is our database server. Let's have a look at how Type 2 hypervisors work with another lab demo. So I'm on my normal laptop here. It's the same one that I'm recording this video on. And if I open up Windows Explorer, if I can find it, here it is. I've actually got a Type 2 hypervisor already installed on here. I'm using VMware Workstation, and I've built some virtual machines on here for a different course that I wrote. So let's go into my NetApp Lab folder, and you see I've got a whole bunch of different virtual machines in here. Let's go and open up Linux A. So I'll fire up this virtual machine, and this will open up in VMware Workstation, and I'll power on the virtual machine, and you'll see it actually starts powering up from the BIOS level. You'll see Linux actually booting up here. So there's Linux booting up. I'll go back to Windows Explorer and go up a level, and you see I've got a Win A virtual machine here as well. This is a Windows server, and I'll open this and power on my Windows server, and you'll see that this will start booting up Windows. So there is Windows booting up. I can see it in the console of my second virtual machine. I can flip back to the console of my first virtual machine, and you can see there is Linux. So I've got my normal Windows operating system running on my laptop, and on top of there I've got a Linux virtual machine running, and I've also got a Windows virtual machine running as well. So let's now go back to the slides and see where we would use a Type 1 and where we would use a Type 2 hypervisor. So looking at the differences between them, I've got my Type 1 hypervisor on the left, I've got my Type 2 hypervisor on the right. You see with a Type 1 hypervisor, the hypervisor is installed directly on top of the hardware. With a Type 2 hypervisor, we've got a normal desktop operating system installed on the hardware, and then we have the hypervisor installed on top of our normal OS. So a Type 1 hypervisor, this is used in a data center. This is a purpose-built box which is dedicated for running data center servers. We use a Type 1 hypervisor because we've got the least amount of overhead. We only have the hypervisor between the virtual machines and the underlying hardware. But this would not be very suitable to run on your own laptop because you'd only have virtual machines running on there. So you can't really run this as a laptop operating system. Then with our Type 2 hypervisor, this is what we are going to have on our laptop. So I've got my normal operating system running on here. I'm running Windows. I've got my normal applications running on top of that, which is what's allowing me to record this video and also what's allowing me to show this PowerPoint presentation. I've also got the hypervisor installed as an application, and I can have my different virtual machines running on top of there. So where this is really useful is if you're an IT engineer and you want to do some testing on Linux or Windows servers, for example, then I can throw that as a virtual machine onto my laptop. It allows me to do really convenient testing. It means I don't have to go and find another hardware box to install Linux or Windows onto. Also, maybe you're in technical sales and you're selling a product that you'd like to give a demonstration of to your customers, and it runs on Linux. Well, again, you don't want to have to carry that around to your customers' offices with you as a separate hardware box. You can run it as a virtual machine on your normal laptop. So in your normal laptop, you can give them a PowerPoint demonstration. You can also give them a demonstration of the different operating system as well.